Alright, we're just going to tell you guys about how you can be more energy efficient, and hopefully you can use this both in your home and your dorm room, depending on wherever you live, you know. But I know, like, when I'm at my dorm and then I go home for the summer and winter, so you can use this stuff there too.
So one of the most important reasons that energy efficiency is important is because of the environmental impact behind energy use. By reducing your energy use, you're going to be reducing your carbon emissions, and you're also going to reduce the country's need for energy imports. Right now, the U.S. uses about 21% of the world's energy resources, but only makes up 5% of the population, which is pretty ridiculous. And a lot of that energy comes from natural gas and coal, which are non-renewables, so those are going to impact our impact, and there's more to it as well that, you know, our carbon emissions, those pollute our air and our waterways, and so if we reduce those, we're also going to see a reduction in health impacts in humans like respiratory problems and heart attacks.
Alright. And then, so saving energy can also save you money. So you can lower your utility bill. Maybe in a year you could save $750 to $1,200. So that could, you know, it's just little changes, but over time they really add up. And it can stimulate job creation. That's kind of cool.
So what all can you do? There's a lot. This is a big list, and it may seem overwhelming, but it's not. So there's basically kind of two categories of things you can do to be more energy efficient. You can have large home improvements, which are things like insulating your attic better, and buying new windows, buying energy efficient appliances, and then like sealing your doors and all that kind of stuff. But our workshop today is going to focus on smaller things that anyone can do in their home or their dorm, like changing light bulbs, unplugging things, taking shorter showers, all that kind of stuff.
Yeah, and it's just about doing a little bit at a time. It's not like, oh, you have to go home and buy a new water heater. You just, you know. Alright, so one of the easiest places to start is just with your light bulbs. So, incandescent light bulbs are really bad, and as I'll tell you about here in a second. But so lighting accounts for 11% of your energy bill. So just by changing to more efficient lighting techniques can save you money. And if all of us converted to light efficient technologies, we could reduce the electricity consumed by 50 to 75%. Alright, and this is an incandescent bulb, which the ones that are not very efficient, a CFL, compact fluorescent light, and then a light emitting diode, an LED, which they were like more popular outside and like in headlights, but they're becoming more and more like used indoors, which is really cool. So incandescents, they convert 90% of their energy into heat, which, you know, it should be converting it into light, but they create a lot of heat. And they usually cost about 30 cents and they'll last almost 42 days. So then if you look at a CFL, they use 75% less energy than the incandescent and last up to 10 times longer. They cost a little bit more, but it's still, they're still, you know, cheaper than the LEDs. And they last a lot longer. And so LEDs, they last 15 times longer, use 75 to 80% less energy than the incandescent, and they last for almost 3 years. So it may seem like a lot when you go into the store. It's like, oh, I'm just going to get one light bulb, and then it's $40. But, you know, over time, you're saving a lot of money than buying a new light bulb every single month.
So the next thing we're going to talk about now that we've talked about lights is plug loads. Plug load is the energy used by devices that are plugged into standard electrical outlets. And, you know, a lot of your standard plug loads are like, or standard things that contribute to your plug loads are, you know, microwaves, hair dryers, toasters, toaster ovens, popcorn makers, space heaters, fans. Like I said, anything that gets plugged into your standard electrical outlet. And your plug load accounts for about 9% of your household energy use, but if you compare that to an office buildings actually use office buildings, the plug load actually makes up about 25% of the energy use, so it's a lot more in the office setting.
Alright, and then so how can you reduce plug loads? So, you know, the first thing you can do is just unplug stuff when you're not using it. But then there's other stuff you can do. So I read this in an article and it was kind of confusing about like which devices you can do it on. But on laptops and maybe TVs and stuff like that, you can switch them to an automatic low power state. And that was like one of the big things that saves a lot of energy to reduce plug loads. So that's kind of cool. You'd have to like look into it and figure it out a little bit, but so that's kind of cool. And then smart plug strips. They have a timer and a sensor, so you just plug your stuff into it, and then it turns it off whenever, you can set a timer so it turns off at a certain time, or just have it go off on its own. So that is really cool. They typically cost like $15 to $30. And then another thing is just regular power strips. Those are good too. And then, yeah, just unplug stuff when you're not using it. It makes a big difference.
So, sorry, I have a question.
Yeah.
So some things, when you leave them plugged in, they are still pulling electricity.
Yeah.
But how do you know which things do that and which things don't?
So a lot of things that are pulling energy without being used are things that have lights on them. So like you may have your laptop plugged in and you think it's turned off, but the little lights blink in there and that takes power. And then you've got other things like microwaves where the time is always displayed on them and that kind of stuff. But there's it's AC versus DC units, and AC I think is the one that is constantly going. It's constantly using energy.
The ones with the 3 prongs.
Yeah, 3 prongs. They're constantly switching back and forth and using energy. But so now that we've talked about how you can reduce your plug load, we're going to actually go out and investigate the plug load of different electrical devices around the science building. So how you're going to do this is you're going to read the electric nameplates, which are little stamps or stickers or a metal plate that tells you about the energy uses of every appliance every electrical appliance. And so up here we have an example of, this is one that is on my reptile lamp at my house, and then there's some more examples on the next slide. You got a coffee brewer and then a laptop one here. And so if you guys look at your sheets, does everybody have a sheet? I didn't miss anyone. Okay. So if you guys look at your sheets, there's also an example of a nameplate on there. But you might be wondering, like, how am I going to find this nameplate on these big devices like refrigerators and stuff? The best way is to look for this little logo right here in the corner. It's UL, which is Underwriters Lab, which is a company that certifies the safety of electrical devices. And that's a good way to point that out. But not all devices will have that. Sometimes they'll have like a little UR logo at the top like this one does. And then another thing that can be kind of confusing when you're looking at these, some of these have input and output on them. So what you're going to be looking at is the input, because you're looking at how much power the device is using, not how much the device is putting out. So you're going to be looking for the wattage, the volts, and the amps. And if not all devices are going to have all 3 of those, some will have just the amps, some will have just the volts, some will have the amps and the volts, some will have the wattage. And so for example, if we're going to read this nameplate here, like I said, we're going to look at the input, and then you have 100 to 240 volts up there, and you're going to have 10.1 amps. And that's what you guys are going to write down in your little chart here. So right now, we're going to go out, we're all going to go around the science building, and we're going to find some devices that have these nameplates on them, and we're going to calculate how much energy is being used per year, and then we're going to convert that into carbon emissions and costs. So once you have your watts, all you're going to do, where did my paper go? So the next step we're going to calculate the cost of running each machine per year. And so to do this, like I said, you've got to estimate about the hours you think it's used per week, and then you're going to multiply that by 52, the number of weeks in a year. And that'll give you your yearly hours it's ran. And then you're going to multiply that by the average electricity rate, which here in Richmond, it's 8.24 cents per kilowatt hour. And so another step you're going to have to take is converting your watts to kilowatts. But that's easy, just divide it by 1,000, or move the decimal place over. Just easy peasy stuff. And that's how you get your annual costs. Okay, so we'll go on to doing carbon output. output, because I think this is the really important part, is seeing how much we use per year. So this is going to follow up pretty much the same format as the last one. You're going to multiply your kilowatts times the hours it's used per year, and then you're going to multiply that by the America's average carbon emissions produced by each kilowatt hour of electricity, which is about 1.6 pounds per kilowatt hour. And that actually varies across the country. And I tried finding Kentucky's rate because I knew Kentucky would be probably higher than the national average because we are so reliant on coal and natural gas. But I couldn't find it, so I just stuck with the national average. What did you find?
I got 197 pounds for the printer.
Wow.
How much for the printer?
197.
Pounds per year?
Nick, what did you find?
The vending machine, I gotta go back to it. It was 26,000.
Oh my gosh.
26,000?
Yeah.
I think this just shows, how much little things and living them plugged in makes a big difference. It produces a lot of carbon, a lot more than everyone thinks. And that was kind of my goal with this, was to show you guys, just leaving something plugged in for all day, like a lamp, or leaving it all on all day, really, really adds to your carbon footprint. So we're going to kind of go on, switch gears, and talk about some other things you can do.
Alright, so another thing you can do is just like weatherize or insulate your house. And so just making sure all your doors and your windows are sealed, that's a big thing because just one small leak can be the equivalent of leaving a whole door open. So you can just use caulk or you can seal them or use like weather stripping. Just do that and you can save 10% or more on your energy bill. And then like this is kind of what the other one was saying, that was more about leaks. So then doors and windows, you want to make sure that they all seal so that, wind or air isn't coming in and making your utility bill go up. So just make sure your doors seal tightly. You can install a storm door. That's really helpful and keeps out a lot of that like cold air, hot air. And then so like in colder weather, like you can let in the heat, and then close your curtains at night or close your blinds, and that can save energy. And then
So back to what she was saying about closing and opening your blinds. That has something to do with active versus passive heating. So active heating is capturing sunlight as either heat or electricity and then using that to augment your heating systems. So an example of this would be like solar collectors that increase the temperature of your water. That's going to decrease your environmental impact. But we're going to focus more on passive heating, which is just letting the sun come into your house and warm it naturally. Which a really good example of this is the EKU, the atrium here in the science building. So the atrium has an overhang over it, and the windows are facing the south, which is the way the sun shines in. And that overhang, what it does is it prevents the sun from shining in when it's high in the summer sky and heating the building up and increasing our cooling costs. Whereas in the winter, when the sun's low, that overhang allows the sun to come shine right in and then heat the building, which reduces our heating costs. So this is something you guys can do at home, like by supporting your heating systems. Is just opening your blinds during the winter and letting that sun shine in. And then in the summer, make sure you keep them closed. And another way you can do this, kind of replicating the overhang of the science building, is by planting trees and stuff around your house, because that creates green space. Plants have many, many benefits, not just to energy efficiency. But
that could be a whole nother witch.
yeah, we could do a whole other thing on plants.
Offset your carbon too.
Yeah.
Okay, so then another really big thing is just using hot water. And so one of the big things that I learned that I don't know, I never thought about is that your washer, when you wash your clothes in hot water, that takes 90% of the energy is just making the hot water, not just washing your clothes. And so we always did that at my house, and I never thought about it, but if you wash it in cold water, it's better for your clothes and it saves more energy. And so heating your water accounts for about 12% of your energy bill. So you could save a lot just by using less hot water. So just try to take shorter showers, insulate like your water heater or the pipes on your water heater, Or, when that one quits working, just try to buy like a more efficient one or change the thermostat on it. There's a few things you can do.
So there's also some things you can do around the kitchen, which, may seem like small. It is small stuff, but it makes a big difference. So using your toaster oven or microwave instead of your oven, because that's a larger appliance and it's going to take more energy, so use those when you can. And then another big thing is keep your oven door closed. So use a timer to make sure you don't have to sit there and check on your food. I read some estimates online that say for every minute you leave your oven door open, it loses 25 degrees. And I tried to do the math to convert that to how much energy it would, or how much carbon it would take to reheat the oven back up, but it was very, very complicated. So, but yeah, just making sure you keep that oven door closed so it doesn't have to sit there and run to keep your temperature hot. And then also defrosting things naturally instead of using your microwave to defrost them. That's an obviously energy saver. And then with your refrigerator, this is something I read that I found really interesting. Just keeping your refrigerator stocked can save you energy because it reduces the airspace inside of your fridge. So whenever you open that door and all that hot, cold air rushes out, and then you close the door, there's not as much airspace for the fridge to cool back down. So that saves energy. And then another thing you can do, if it's more of a home improvement, is switching to an induction stove. Those use magnets to heat up your cooking vessel instead of like a conventional stove uses thermal convection, which there's a lot of heat loss in that. Whereas if you use a induction stove, you're going to get the heat directly to the cooking device. Yeah,
That's it. That's all of our tips. These are some of the important ones. Yeah.
So I think the biggest point from this last slide is that if we all commit to being more energy efficient, we can reduce our carbon. Just the U.S. we can reduce our carbon emissions from energy production by 57%, which is a big deal. And because right now, like I said, we use almost the most out of everyone in the world, and we only make up 5% of the population, it's ridiculous. So we all have to take steps to reduce our energy impacts to fight climate change.
And it's kind of like when you're going like zero waste or like a more plant-based diet, and this is like the same thing. Like you can just do little things at a time. You don't have to just like go home and change everything you're doing. Just change your light bulbs when they go out or buy some new light bulbs. Just little things.
So, thank you guys for listening to our tips and stuff. I hope you guys take this home and